So good morning all. In this video tutorial we will learn some numerical problem based on digital image processing from the topic histogram. So the first question that we have, it is related to histogram equalization. So in this question you can see it is a 3-bit image. So if it is a 3-bit image, it means n is equals to 3, the number of grayscale 2 to the power n, so l is equals to 8. The size of this image, it is given 64 cross 64, and for an image for 64 cross 64, the total number of pixel in it is 4096. And for this image we have this pixel distribution, and on this pixel distribution we have to perform the histogram equalization. So let's start this problem. So for histogram equalization you need to make in order to solve this question you have to make a table like this. In the first column you have to write the grayscale level. So in my image this RK represent the different gray level present in my image. It varies from 0 to 7. So I will write like this: 0 1 2 3 4 5 6 7. In the next column you have to mention the number of occurrence of each gray level, that is the number of count. So nk in the question it is given. For 0 gray level it is 790, for 1 gray level it is 1023, for second gray level it is 850, and so on. So we will write like this: 790, 1023, 850, 656, 329, 245, 122, and 81. So if you count all these number of occurrence, you will find the total number of pixel, it is 4096. In the next step you have to make the normalization. That is, you have to determine nk by n. What is n? It is the total number of pixel. So what is n? It is the total number of pixel, that is 4096. So we have to normalize all these values. First, 790 divided by 4096, numerically it is 0.1928. So in round figure up to 2 decimal place it is equal to 0.19. Next, 1023 divided by 4096, in numerically it is 0.2497, and in up to 2 decimal place it is 0.25. Next, 850 divided by 4096, numerically it is 0.2075, and up to 2 decimal place it is 0.21. Similarly, if you determine for the others, it is coming to be 0.16, 0.08, 0.06, 0.03, and finally it is 0.02. After determination of nk by n, that is the probability density function, next you have to determine the cumulative density function represented by sigma. So the first value, it is 0.19. Next, 0.19 plus 0.25, it is 0.44. Next, 0.44 plus 0.21, it is 0.65. Next, 0.65 plus 0.16, it is 0.81. Next 0.81 plus 0.08, it is 0.89. Next 0.89 plus 0.06, it is 0.95. 0.95 plus 0.03, it is 0.98. And last 0.98 plus 0.02, it is 1.00. After determination of cumulative density function CPDF, next you have to determine L minus 1 into sigma. L minus 1 into sigma. In question it is clearly mentioned L is equals to 8. So if L is equals to 8, L minus 1 is equals to 7. So 7 multiplied with 0.19, it is 1.33. 7 multiplied with 0.44, it is 3.08. 7 multiplied with 0.65, it is 4.55. Now 7 multiplied with 0.81, it is 5.67. Next 7 multiplied with 0.89, it is 6.23, and so on. If you determine the remaining values, it is coming to be 6.65, 6.86 and 7.00. And in the last step you have to convert this number into its nearest integer number. So I will write the output gray label represented by SK. So 1.33, the integer equivalent is 1. 3.08, its nearest integer equivalent is 3. 4.55, its nearest integer equivalent is 5. Similarly for 5.67, it is 6. For 6.23, it is 6. For 6.65, it is 7. 6.86, it becomes 7, and 7.00, it becomes 7. So this is the first step. And this step it is called as histogram equalization. Next we will make a output table. Now we will make a output table, and this output table it consists of 3 columns. In the first column you will mention the equalized gray label, that is the output gray label. In the next you have to write its number of count for each gray label, and in the third column you will determine the normalized number for each gray label. So look at the histogram table. In histogram table, this 790 number of pixels, it is earlier assigned to the gray label 0, and after histogram equalization this 790 number of pixel is assigned to the new gray label 1. So I will write here 790. Okay. So in my output table, the number of pixel assigned to the new gray label 1, it is 790. Next 1023 number of pixels in the input, it is assigned to the gray label 1. Now after performing the histogram equalization, 1023 number of pixel is assigned to the new gray label 3. So in my output image, the number of occurrence of gray label 3, it is 1023. Next 850 number of pixel, it is assigned to the new gray label 5. 850 number of pixel is assigned to the new gray label 5. 656 and 329 number of pixel is assigned to the new gray label 6. So I will write 656 plus 329, it is assigned to the new gray level 6, and the sum of both it is equals to 985. And in the last 245, 122 and 81 number of pixels, which is earlier assigned to the gray level 5, 6 and 7 respectively. Now these 245, 122 and 81 number of pixel, it is assigned to the new gray level 7. So I will write 245 plus 122 plus 81, and sum of these three number it is equals to 448, and the remaining gray label you will assign with the number 0. Okay, so this is my output histogram table after performing the histogram equalization. And if you determine the normalized equivalent, so again if you add all this number 790, 1023, 850, 985 and 448, the total number of pixel it is coming to be and it will coming to be 4096. Now for normalization, each of this number will be divided by the total number, that is 4096. So if you divide 790 by 4096 in 2 decimal place, it is 0.19. 1023 divided by 4096 up to 2 decimal place, it is coming to be 0.25. 850 divided by 4096, it is coming to be 0.21 up to 2 decimal place. 985 divided by 4096 in up to 2 decimal place, it is coming to be 0.24. and last 448 divided by 4096 in 2 decimal place, it is coming to be 0.11, and the remainings are 00. So what is the conclusion? If you observe the input histogram, you will find in normalized sum of the gray label it is 0.19, 0.25, 0.08, 0.06 and so on. And in the output histogram you will find the normalized number nk by n, it is 0.19, 0.25, 0.21, 0.24, all having the normalized number close to 0.2, and hence this histogram equalization process, it offers a nearly flat histogram in its output.